What is up, guys? It is time for another CS 1110 review video. Alright, so now we are on Exam 2, and I will not be covering many topics from Exam 1. If you want to see those, you can just go look at the video that's also on this playlist. And these topics will, probably, most likely appear on this exam, since like they, build off each other, So, alright, let's just jump right into it. I'm going to be following this magical list, which you can find if you go to, like, the CES website and go to Schedule and click on that topics list. So, yeah, so here are all the little things you gotta know, and I'm just gonna be going through each one of these and playing around with them. So, alright. So first we have Boolean values, like true, false, and the operators that go with them. So what can these do? So we can store these values inside of something. So I can say like x equals true, and a key thing, true. And a key thing to remember in Python is that true and false values are with a capital T. If you're coming from Java, it's going to be like a lowercase t. Just remember that for this test, the capital and lowercase t's and f's. And yeah, so that's fine. And I can also say like y equals false and stuff like that. And then you can print these out just like any other variable. Like I can print x. And over here, and this is just using a terminal. Don't freak out; it looks different than PyCharm. But yeah, so that just prints out x, which was true. So there we go. Now, when do we use this? Like, what's so great about having x and y values are true and false? I like to store strings and stuff. Well, we can use these values to do different things. So you've probably seen your if stuff, because your if clauses are from. Oh, do we not cover if in Exam 1? Oh, I guess not. All right, so this is used usually with if statements. This is not even on the list. Oh, you know what? It's probably in those like extended ones. And yeah, it was on Exam 1. All right, so yeah, use them with if statements. So I can say like if true, print x. I can say like if false, then I'm going to print y. So if false, then we're going to print y, but this will never ever run, right? Because false is never true, which is when if runs. So we're just going to get true, which is x showing this. And just to make that clear, I'm going to say like print high, and there we go, it's high. So that's kind of when we use these. We can also well, see, we have a value in here, and then we have this thing. This is still just a literal here, but we can actually go ahead and just put the value of x right there. So this is saying if x, which is true, then print out high. So we can do that. Then we have these things that can go with these things. I'm sure you've used this in a homework assignment. So we can say if x and y print high, what is this going to print? Well, it prints nothing at all because yeah, we have this is if true and false, which if you have true and false, that an and is looking for both sides to be true, and one of them is false. So then this doesn't run, and if false just never runs. This might as well just be nothing. And that's a kind of a neat trick when you're say you have like if all this stuff and like you're have all this other code, and you're like, what, I really just don't want this to run right now. You can just add a little and false. Usually, it usually works for that. Just like completely just disables it for a bit instead of having to comment it all out or something. So yeah, I'm assuming you guys know what and or not is, but let's just go ahead and look at it anyway. So I can say if true and true, print. Let's say yep. So this is going to work, right? Because and looks for both sides to be true and true. And if I make one of them false, then it's going to immediately be, I'm going to put an else here and say like else. I'm going to say print, sorry, I typed so slow, print no. And you can always speed me up because I type so slow. But yeah, so this is going to print no because this evaluated to false. And it went to the else case, right? So, and then, obviously if I make them both false, because it's an and, it's going to do that. And so I can also change this to or. Now, or checks to see if one side or the other is true, in which case, right now, it's not. But if I make one of these true, there we go. If I make that true, then it will be to yep. And yeah, now all that not does is just that not is going to invert whatever it's looking at. I think I usually put it in, I think this is how it works. Yeah, I just put it in parentheses around the whatever I'm looking at. Some of you coming from Java, you're probably thinking of this sign where it looks like that. Yeah, but I think you can actually just like put like this, maybe. This like might work sometimes. Yeah, because this is saying like if not true there. But I usually like to just put it in parentheses just to be safe, So that's saying if not true, which is false, right? Or false. So false or false is not going to print. That's going to print no. All so I'm going to set up a challenge for you. I don't know if you're going to make you do this on the test or not, but probably not, in my opinion. But what will this print out when I run it? Is it going to print yep, or is it going to print no? Give it a second, think about it. Yeah, so we can actually evaluate this from the inside out. First of all, the answer is like right here totally the whole time, but it was yep. So we can evaluate this from the inside out. So not true is going to be false, right? And false is going to be false, and then not false is going to be true, right? You just follow the parentheses like that. And that's kind of why I like to put parentheses, so I can keep track of what's going on. And sometimes when you see this this not operator going on, it's usually with this like in thing. So like I think we're gonna get to in a little bit later. I bet, yeah, element in list. We're gonna get to that later. But yeah, you can usually see like if this is saying is or saying if the substring 1 is in this string, then x is, oh sorry, I have two x's defined here. So if the x is a string and we're saying is 1 in the x, and then we're gonna print yes if not, and no. Or yeah, so that we get a yep because it's in there. But usually when the reason I put this in here is sometimes you'll see like it says like not in x. And that's like a cool way to write it because it kind of looks more like English, not in x. But another way you could write it is just say like not and then 1 in x. And that's usually how I like to do it because I think it just seems straighter in my mind. This is going to do the same thing, still no, right? So, all right. So I think I way overdrew like everything we need to know about and or not, but I'm pretty sure you guys understand what's going on. By the way, if you have any questions on stuff that I have, if I said something strangely or something, all the comments on this video are directly linked to my email, so just go ahead and comment and I'll be able to respond to that. All right, so what are we on to next? Let's see, Boolean values and test case selection and debugging strategies. Okay, that is something that you were probably taught in lecture. So I'm just going to go ahead and skip that. That's cool. You just go back in your lecture notes. I mean, if you don't know what lecture notes are, like, you just go to Lucid and then, like, schedule. Oh, crap. Sorry. Don't look at that. Schedule. And then, like, yeah, find the lecture there's there. I mean, you know that. All right. Oh, okay. Loops. Loops is the one I want to talk about. Okay. So let's, so why do we even have loops, first of all? I was just making sure my recording was actually going. So why do we have loops? So let's say that, you had an assignment where it said, I want you to just print out hi 900 times. So you're like, okay, I'm going to do print hi, and then I'm going to do print, and then hi. And if you're tech savvy, you can copy and paste a bunch of times. Still, that's going to take forever, and that code is just going to look ridiculous, right? I mean, it does work, but so how would we be able to loop? Sorry, I got off track. But the reason that we have loops is so that we can do things multiple times, and you totally know that. And yeah, okay. So there's two types of loops, and give me a sec. There's two types of loops. One is a while loop, and one is a for loop. And I have not found a case yet, but if you can prove me wrong, let me know. I think that you can do everything that you can do with a for loop with a while loop because you can simulate a for loop within a while loop, which I'll show you how to do. So we're going to start out with a while loop because I like to think of that as like the most generic case of loops. And when you think of when they were designing Python, they said, okay, we have these lines of code. What is going on? Yeah, we have like these lines of code going on. What? This text completion. Okay. So they have. Sorry. They're like, okay, we have these 4 lines of code, and they're wanting to loop things. How can we add this loop functionality? Well. And actually, I guess Python did make the while loop, but let's just pretend they did. All right, so they could say, you know what? How about we loop through these just until they say to stop? Like that's a good way to do it, right? So we can set one of our booleans here. We can say x equals true, and we can say while x. Then we're gonna do something. Let's say we say print hi. You can put as many lines here as you want, And so this will be totally fine, and however, this is going to run forever, right? Because we never changed x, and that's a good case, like a red flag to see in your head. If you have a while loop that's based on some variable and you don't actually change it in the thing, it's never gonna, or most likely, it's never gonna stop. So I'm gonna go, how do I stop an infinite thing on here? Goodness, there we go. Okay, so instead, what do we have to do? Well, we can say like, what's something we can do? How about we just immediately set it equal to false? So we say x equals false. And then yeah, this is only going to run once, right? Because it says, all right, so while x, so I'm going to, okay, x is true, okay, let's go in, print high, okay, oh, x is now false, okay, and then while x, oh, x is false, then we skip down and keep going, whatever the rest is down here. So, and then you can, do other stuff too. Let's, how about we say, we set x equal to 0, we say, while x is less than 100, then we're going to print high, and then we can say if, and say if x is, wait, yeah, we don't need that, sorry. I'm getting off track. Yeah, so, yeah, this will print high, hold on. Yes, I was thinking in my head we had to do something to x. Yes, we have to do x plus equals 1, and this will print high 100 times. Let's do it. Bam, that was only 100 times. You can count them up if you want. But yeah, just 100 times. It's hard to see on the video. Let's do 10. And I mean, I'm sure you guys have all done this in your homework assignments, but I'm just boiling everything down in this video. So yeah, feel free to skip stuff that you've already seen before. The reason I was saying that you can simulate a for loop with a while loop is, well, we just kind of did it, right? So say like, you want to do something, and you know what the for loop is, right? Like, because a while loop says that we're going to do something until like this condition is false, or not at all if it already is false, right? But a for loop is like, I want you to do it like this many, like an X number of times, right? So in this case, we said, all right, we're going to print X 10 times, right? So then this is printed out 10 times. And actually, I can print out X too. You want to see like the count, the counter rate going up. See 0, 1 through up to 9, and that's kind of similar to a for loop. So let's just jump into this for loop here. So, actually, I feel like I haven't fully exhausted the while loop yet. I'm going to keep going. You can feel free to skip if you want. But we can have like this, while true or something, and print high, and this is totally just going to run forever, right? And like, yeah, it's going to just keep going forever. And actually, I can get back that like counted one we were doing, where like, yeah, like this. Sorry, give me a sec. So there's multiple ways that you could implement this same functionality here. So let's say we print out this x, and then I'm going to have this like Boolean. All right, let's not even do that. Let's just say while true. So this is definitely going to run forever, right? Well, we can actually find a little hack around this. A lot of people say this is very sloppy though. So we can go in here and we can say if x is and I'm using parentheses on everything because I'm just so used to it in Java. You don't actually need those, so I guess I can get those away. Sorry. So we can say, if x, then I'm going to say, if x is greater than 10, then I'm going to break, and that will end the while loop. So let's try that real quick. Yeah, so that works totally fine too, right? Because it's going to say run forever, but if it's greater than 10, then just break. And some people find this is kind of sloppy because they say that when you use a while loop, you should be using this condition up here to find out when you're stopped. So you just put this x is greater than 10 up here, just get rid of this whole thing, and then that works totally fine too, right? Wait a minute. While x is less than 10, right? Got to work with that logic. There we go. All right, so I don't know what that is. Okay, and then one other thing I was going to say is you can have something called a sentinel value. And what this is, I'm going to just leave this term on the screen here. So if we have like y equals true, I can say like, let's see, let me say while y, this is going to keep doing this while y is true, right? But I can say if x is greater than 10, then I'm going to set y to equal to false. And then that will do this exact same thing too, except, well, I guess just one extra. And yeah, I did do that before. I don't know, you can figure out why I did one extra. But yeah, so this is called a sentinel value because you're basically like setting this this flag up. And sometimes a lot of people call it a flag like this. And then, so you know that when you get a flag to stop, then that's when you stop your while loop. And yeah, that's so if you ever see the term sentinel value on the test or whatever, then that's what that is. All right, so I feel like I've totally exhausted this while loop thing now. So let's move on to for loops. So basically, a for loop, when they were designing a for loop is like when you want to do something a certain number of times. And how many times are we going to do it? Like, maybe they could code in, say, like, for, like, 5 times or something. Like, but they're like, that doesn't seem quite right. And so really what they did, and all that we've done with for loops so far, and correct me if you find one that doesn't fall into this case, is it's always it's like for something in some a range of values. So, or let me say that a lot better. So say we have some kind of collection thing, and I'm just going to put a bunch of C's up here, and what the heck? Okay. Yeah, so you have something like this string or list or range thing or tuple or anything with some number of things in it, and you're going to do something for each number of this. And they just thought that was a better way to do it because, well, you'll see why. So I'm just going to say, let's have x equals 1, 2, 3, 4, 5. And I'm going to say for I in x, I'm going to say print I. Okay? So you've seen this. So for I in some list, I is going to be whatever x is. And by the way, this does not have to be I. I can call this pizza if I want. In fact, I'm going to. So for each pizza or each element in x, we're going to do something. What are we going to do? Well, we're going to print out that actual element, which is pizza. Because the reason you have this variable in here in the for loop is so that you can like reference like what thing in the thing you're looking at. So yeah, so we can print that out just fine. And sometimes you'll see something a little different though, where you see for pizza in range of let's do 4, right? Because it goes 0, 1, 2, 3, 4, so that'd be the same number of things. And then I'm going to print out pizza. So this is going to start at 0 and go 0, 1, 2, 3, 4, or 0, 1, 2, 3. Yes, because it stops, right? It doesn't include that last one, right? So then this would be 0, 1, 2, 3, 4. And so basically, what is this range thing? Because I got what we were doing when we were doing for pizza in this list thing. We were printing out each element of the list, right? And just to be more clear on that, I can like change it to like 7, 4, 8, 1, 2, and it's literally just whatever thing is inside of this x thing, like 7, 4, 8, 1, 2. But when I do this range thing, range 10, say, where are these numbers coming from? 0, 1 through 9. Like I just see range 10. Well, you could basically think of range. One way to think of it is basically the same thing, like with a list that starts at 0, 1, 0, 1, 2, 3, 4, 5, 6, 7, and yeah, so except just don't like try to like do range dot append or anything you would do normally with a list. That's just a good way to think about it when you're thinking about the for loop. Is it's each item in this range element. I'm just gonna like change the thing so it looks different from the list. It's like each thing in like this object, this range. And actually, if we look at what range is, if I say hey Python, give me the type of range 10. It's going to say it is an object, a range object from the class range. And you'll work with objects more in 2110, but basically it's just like a thing that isn't, it's more complicated than just like an integer. Or actually, I don't want to get into that, sorry. So yeah, so this basically sort of, in my mind, it kind of generates, actually I want to show you more stuff first. So let's say for pizza in y, and what is y going to be? I'm going to make this a string of 0, 1, 2, 3, and then we'll do 8, 8, 8, just so you know it's different. And then, yeah, so this is going to say, all right, for each item in y, and what is each item? Well, each item is going to be each character. That's what we decided. And it's just going to print out that character. So we have, sorry, wrong command. This is going to be 0, 1, 2, 3, 8, 8, 8, just like that. So that's like another thing you could do. And, what if we had a dictionary? Say z equals, I'm going to say, let's say we have 1 goes to 5 and 2 goes to 4. Do you have to put commas in here? I can't even remember. Hold up. Yes, you totally need commas. Sorry about that. Yeah, so yeah, we have these keys in here. I'm going to make, let's make a, let's say hello goes to, let's say that goes to pizza, and then, I don't know, like 6 goes to a list of 1, 2, 3. And remember that I'll get to dictionaries later. I don't want to go into that yet. But if I say poor pizza in this dictionary Z, well, they said, well, what's each? It's going to go through each element, right? But they decided to make each element in this case just be the keys. So it's going to be print out each of the keys: 0, 1, 2, 3, hello, and 6. So yeah, that's basically all a for loop does. It goes through some, I'm going to do like an extra one. I'm so sorry I'm trying this out. If for A will make a tuple. Yeah, you probably haven't worked too much with tuples yet, but I can do this, and I can say for pizza in this tuple AA, it will print out 1, 4, 2, 7, 3, 4, just like that. So basically the point, my giant point here, is that all a for loop does is it goes through some collection of stuff, and it does something for each of those. And remember, we don't actually have to do anything with the value. Like I can say print high, and it's just going to do that the same number of times as the number of things in here, right? It's just going to go through each element and say like, all right, I'm on number 1, but they just print high. Okay, print high. I'm on number 4. Okay, just print high. And if we want to deal with the actual one, we do that. Put the actual variable name there, and then there we go. So my point with all of this, dragging this out, so there's kind of like, in my mind, there's really only like one type of for loop, right? It's just like for I and something, but still in practice, it seems like you kind of use either for I in the actual thing or for I in a range. So I'm going to show you both of those, because although these are still doing these like the exact same thing, so just I'm gonna show you the difference in them. So I can say for I in X, and I'm going to print I, and then I'm going to say for I in range to the length of X, and I'm going to print. Now this one is going to print out each element of X, and I want these four to do the same thing. So do you think of what I'm going to put here? Well, I'm going to index this list, and I think we get to indexing later still, but I'm going to index this X with this I for my range, and there we go. Yeah, and so this is going to do 74812. I'm going to print a little break here so you can see the difference in the stuff. And then, yeah, so see it's 74812 and 74812 right there, and these do the exact same thing. So what is the difference? So we have for each, basically whenever I read a for loop like this, I like to think for each item in what? For each item in X, we're going to do what? We're going to print that item, which is I. And just to be clear, we can call whatever we want. I like to keep in mind that not all things have to be what we always make them in computer science. But yeah, so it's going to print out each element. And what does this one do? This says for I in range up to the length of X. And well, what is the length of X? First of all, we have 1, 2, 3, 4, 5. So that's going to be like our range object. And remember, this is not correct syntax. This is just for you to see. It's like it's going to start at 0, and it's going to 0, 1, 2, 3, 4. And this is 1, 2, 3, 4, 5. Yeah, so it's going to go up to, not including the length of X. And so each time, what I is going to be, so I'm going to print I is, and then comma I. Now I'm going to say X of I is, and feel free to skip ahead if you feel like I'm dragging this out too far. But oh boy, I didn't take this out. Sorry. Is there a need? Oh yes. I'm always remember that command slash will comment things out for you. Very nice. Yeah. So go through. If we're going through here, I is going to be each item in this range thing, which is 0, 1, 2, 3, 4, up into, and not including what you passed in here. And then we're going to print out I is going to be the number in this thing. And then when you can use this to index this thing. So see, I is 0, but X of I is 7. I is 1, X of I is 4. And I think that's just a really important thing when you're coding, is just to know what your I's are, or know whatever this pizza or whatever you called it there, know what that actually is, so you can go ahead and do it. And you know what? Even if you're still confused on it when you're working on your assignments, I would just start out when you write a for loop just printing the I, so you can see what it is, what you're working with, and then you can go ahead and say, oh, okay, it's each number, so I can like go to and index that thing. So there we go. And one neat way, like when I know you're going fast on a test, two neat tricks. First of all, is if you so range. I think we might talk about this later. It might have been in the Oh, we do here. Yeah. So I'm gonna get this in a little bit, but you know how range you start it. You can go 0 up to like 10, but you can just put in 10 and it's the same thing, 0, 1, 2, 3, 4, up to 9. But remember that it doesn't include that last element. So, and also the biggest, even though the length of X is 5, we only really want to do X up to 4, right? Because this goes 0, 1, 2, 3, 4. So what's neat is if you just pass in range length x, that's going to do every single item in x. So 7, 4, 8, 1, 2, like that. That's just a neat way, like when you're going fast on a test, is be like, oh, I got to do each one in x. Just put the length, in the range, and then it will get each one. And then, well, unless you're like, if you ever like delete like x of I, this is going to cause problems. We're going to like go out of the range of the thing, right? Because now we're like shortening it, and then this for loop is going to go ahead all the way on until 5, and then so deleting inside of a loop is usually a bad idea. But I'm getting off track. Another thing I was going to say is if you want to say for range 10, for I in range 10, and I'm going to say print high. I'm actually going to do range 5 so you can see it better. This will do it 5 times. If you just put a 5 in the range, it will do it 5 times, which is a nice way to think about it. See, 1, 2, 3, 4, 5. And the reason this does that, because it starts at 0 up to not including 5, so it goes 0, 1, 2, 3, 4, 5, and then, 4, and that's 1, 2, 3, 4, 5 different things. So, yeah, that's why you can just put the number in there. If you say, I want it to do it this many times, just put the number in range. And those are just 2 ways to easily remember it. So remember that for while loops are going to go while whatever is your condition is true. Like if I say while x and y, then this will keep going until one of these is false. And then with the for loop, it's basically just going to say for I in something. So for each item in something, I'm going to do something. And I can also use this I to look at the something that I'm on too. Okay, that sounds super abstract. Okay, so collection types. Okay, so what is a collection? Well, a collection is a bunch of stuff in a thing. So what are our different types of stuffs in things? So we have strings, right? Actually, what's neat about collections is they read to for loops just as broken, right? So I'm going to put my string boy equals hello, and then what do we have? A list, and then I'm going to say listy boy equals 1, 2, 3, and then what's next? Tuple yay equals 1, 2, 3, and wait, are these like, hold up. It looks like we're going to get more into these later with like the element, the methods on these things. So we'll hold off on those for a minute. I just want to show you how to write to for loops again, I guess. So we have tuple, and then we have range. Let's say rangy boy. Sorry, equals range 20. Say. So if I say for I in string boy print I, you tell me what this is going to print out. Ready? And go. HELLL. Good. Okay. Now if I say for I in listy boy, what is this going to print out? Ready? Go. 1, 2, 3. There we go. I'm going to change this so it looks different. 1, 2, 6. So if I do tuple, yay, what will this print out? Ready? And go. 1, 2, 6. All right? Because it's going, and for each of these, it's basically just saying for each element, print out that element. Okay? And then, we got the last one, range 20. So if I say for I in rangy boy, rangy boy, and then print out I, what is I going to be? Well, you're right, 0 up through and not including 20. So there we go. And you've never seen this before, like where you store range in a variable, because no one like ever does that ever. But I mean, range is a thing. Like it's like a string or a number. It's a thing in Python, technically an object, which you'll get to in 2110. But it's a thing in Python, and you can store it in a variable just like that. All right. So yeah. So like we're gonna get more into these. Looks like down here. So I guess I won't drag those out too much yet. So okay. Is it time for? You know what? I actually don't see the basics of these, so I'm gonna actually go through them. Okay, so I feel like you know strings from exam 1. It's literally just like in quotes, you put stuff in there, and that's totally fine, right? And this doesn't crash at all. And you know what? You've done like the concatenation of strings and stuff, and like and we just saw how you iterate through them. So I'm gonna assume that you know that. If you don't, just go look at my exam 1 video. And then for lists, yeah, so you have like brackets, and each item has this things. And we can mix the types of items. I can say hello. I can say, ooh, I wonder if I could put a range in here. Any kind of thing that we can put in Python. I'm going to see if this crashes. See if it crashes. Oh, no, totally. I can do that. And then let's keep going. What's another thing that we can put in here? Let's say false. And then let's say about true. True. And then let's put another list, because a list is a thing, right? Let's do 1, 2, 3. And then let's do a empty dictionary with nothing. Or actually, let's put a 3 goes to 4 in here. And actually, usually, I think you can go ahead and put an extra line, but sometimes it gets mad at you if you do that. Yeah, it's totally fine. Yeah, so now we have x is 1, hello, range 10, false, true, 1, 2, 3, and a dictionary containing 3, mapping to 4. I don't know why you would ever use this, but let's print them all out. Let's see what it looks like. So I'm going to do 4. I'm going to say 4, shoe in, x. I'm going to say print out our shoe. So what is this going to print out? I wonder. Oh, okay, so it's going to do each one, right? So we have 1, we have hello, we have range of that, we have false, we have true, we have that thing and all that. And, yeah, we can do more things than printing them out, by the way. Like if I have and I know you guys know this, but like if I have like a list of lists like this, like a bunch of lists, that's not right. Yeah, and then I can like, say not just print things. I'm gonna like, say shoe.append. We're gonna get to appending in a minute. Append 10, and then I'm gonna say, after this for loop, after it, I'm going to print x and see if it's different now. Yes, now every list in this list has 10 added on. I just want to show you that you just don't have to print out. You could do stuff with the shoe and actually modify it, and it will actually change in the real one. Yeah, this is a oh, give me a sec. My mom's calling me actually.